Our task here is to find the domain of each rational function, and we're going to write our answer in set builder and interval notation. Okay, and we have been given the formula for all of these functions, so anytime we're talking about domain and range, I encourage you to go to the graph and look. Right now, I just want to concentrate on the algebra here. What is it that we need to be looking for here? Okay, and also notice I'm not asking about the range, I'm just asking for the domain. Algebraically speaking, that's the one thing that we know we can find for sure based on the formula. So in all of these cases with a rational function, we have a variable in the denominator, right? And so what is problematic about that? Well, you can't divide by 0. That's the whole deal, right? We can't divide something into 0 parts. So something divided by 0 is an undefined situation. So if there are values that make the denominator 0, those cannot be part of the domain. Those aren't values of x that will give us a real number output for y. So in each one of these cases, that's what I want to be asking myself. What makes that denominator 0? So in the first case, I have r of x is equal to x plus 1 over x squared. So when we're being asked about the domain, I care not what's happening in the numerator. I just want to know what makes that denominator 0. So I want to take the denominator, set it equal to 0. If I take the square root of both sides, right, you get x equal to 0, right? Okay, so what that means is that x can't be 0, right? So in set builder notation, I would say I have the set of all x such that x is not equal to 0, meaning x can be any other real number and we'll get a real output for y, but with 0 we'll have an undefined fraction. So generally speaking, you'll be asked to state it using one or the other of these notations, but I want to get us used to using both. So in interval notation, we think about the number line, right? We're including everything on the number line except for 0. So negative infinity up to 0, and open bracket at 0, right, in union with 0 to positive infinity, right? Now, let's do this next example. We have s of x is equal to x plus 3 divided by x squared plus 16. Okay, I'm asking myself once again, I see the variable in the denominator. Is there anything that makes that denominator 0? Well, x squared plus 16 isn't factorable. It's a quadratic. We can factor the difference of squares, but we can't factor the sum of squares. So there's no middle term there. So I'm just going to, let's try this. Let's subtract 16 from both sides. So I have x squared plus 16 minus 16 equal to 0 minus 16. And so I have x squared equal to negative 16. Are there values of x that make that statement true? Real values of x. If x is negative and we square it, it becomes positive, right? If it's positive and we square it, it's positive. There's never going to be a number that will get us to negative 16. If you take the square root of both sides, technically we would have plus or minus the square root of negative 16, which of course is plus or minus 4i, right? So we could define it in terms of an imaginary number, but there's no real number solution for that, right? So I would say that the domain is the set of all x values that we can put in there, and we can put any real number in there. So that's what I would say. I would say the set of all x such that negative infinity is less than x is less than infinity. Or you could also say negative infinity to infinity in interval notation. Open brackets at negative infinity and infinity, right? We can't get there. If you set the denominator equal to 0 and get imaginary solutions, then that means that x can be any real number. It doesn't matter what we put in there for x, we'll get a real number back for y. Okay, so let's look at q of x equal to x minus 6 over x minus 6. Okay, now there's one thing I notice. X minus 6 over x minus 6 is equal to 1, isn't it? But we still have to say that x can't be 6, right? Because we're still looking ultimately at that denominator and saying, okay, well, x minus 6 equals 0, so I have to add 6 to both sides, right? And so x is equal to 6. And so in set builder notation, we'd say the set of all x such that x cannot be 6, right? So even though that'll simplify to 1, we still have to say that x equals 6 is not part of the domain. Okay, so then we would say negative infinity up to 6 in union with 6 to positive infinity for interval notation, right? So if you're just eliminating one value, essentially you have two intervals, right? With open brackets at that value you want to exclude. Okay. All right, so let's look at this one. P of x is equal to x minus 7 over x squared minus 7x minus 18. Okay, again, I'm just concerned about that denominator, right? Because I'm wanting to know about the domain. X squared minus 7x minus 18 equal to 0. And it's a quadratic, and so the first thing I want to ask myself is, okay, well, does it factor, right? So factors of negative 18 that add to negative 7. Well, I'm thinking 9 and 2, right? We got to get the positives and negatives lined up here. But to get a negative, I'd say x minus 9 and x plus 2, right? Negative 9 plus 2 is negative 7, and negative 9 times 2 is negative 18. Okay, so now that I have this factored, I know that either x minus 9 equals 0 or x plus 2 equals 0, right? And over here I have to add 9 to both sides. So that will give x equal to 9. And over here I have to subtract 2 from both sides. And by the way, if you're to the stage now that you don't really need to show that step, that's fine. And often you should get to a stage where you can just look at those factors of x minus 9 and say, well, if x is 9, that's going to make that factor 0. X plus 2, well, if x is negative 2, that's going to make that factor 0. Okay, so we know that x can't be those values, right? So I'm going to say set of all x such that x cannot be negative 2, and also x cannot be 9. Okay, and on the number line, I'm going to have 3 intervals, right? So negative infinity up to negative 2 in union with negative 2 to 9 in union with 9 to positive infinity, okay? And if it's helpful for you, you can put it on the number line, right? And essentially you have open dots at negative 2 and at 9, but you're including everything else on the number line. Okay. Like I said, I encourage you to go to Desmos and graph any of these. Take a look at what's happening with that. We're going to look at some things graphically coming up.